Welcome. So, in the earlier lecture, what we were primarily talking about was the global water distribution and usage. If you recall, we ended the session when we were talking about the how the water usage changes when we move from low and medium income countries to higher income countries. So, that way this is what we were discussing. If you see the global water withdrawal, again these are the estimated number available at a website. So, it suggests that the water withdrawal as a percentage of total available water, because of the higher availability of water, is less than 10% in many of the European and these zones, or 20 to 10% ranges, whereas the area that are more critical in terms of water availability and all that. So, if you see the estimated number for 2025 says that around annual water withdrawal, or the percentage of water withdrawal totally, would be more than 40% or in India, and of the order of 20 to 40% in the China, in this zone that you can observe over here. Anyway, so let us come to India, how things are managed in India, because as we were just referring at that different countries, based on their development status, based on their economy, based on the available resources, the water consumption practices, water use practices are also different, water availability is of course different. So, the condition is not very bright for India, as were apparent from the earlier discussions. So, India, these are some general information as per Ministry of Urban Development. The total population in 2008, so as per MOUD, had improved drinking water sources. Around 88% of population has drinking water sources. The 96% of urban and 84% of rural population has access to the improved drinking water sources. However, this access to drinking water sources does not mean the household level water supply. So, when we say that access to safe drinking water source, rural population has 84% rural population has access to safe drinking water sources, what it primarily reflects that there are some clean water resources in the vicinity, or in either in the form of groundwater or surface water in the region, that can feed in to the 84% of the population. So, those kind of estimates are there. If you see the total population and all these numbers, GDP numbers are available over here. Coming to the water availability, some key points, that India has more than 17% of world's population as of now. However, we have only 4% of world renewable water resources and just 2.6% of the world's land area. So, you see that dealing with more around 17% of the total population, however, left with only 4% of water and even less land. The annual precipitation in the India is estimated of the order of 4,000 kilometer cube, okay, of which around 75 to 80% of the total precipitation of the annual precipitation comes during the 4 monsoon months, starting from June to September. The basin wise average annual flow in the rivers, we have several river basins, major river basins, various minor river basins or sub basins, that way that one can see in the image here sourced from India's water future IWMI report published in 2007. The Ganga river basin, which is the largest river basin that way, and there are various other sub river basins. There are different amount of water storage capacity in the different basins that we will talk about. If we see the average, so basin wise annual average flow in the rivers in India is close to 1950 kilometer cube, whereas utilizable annual surface water is little under than 700 kilometer cube. The groundwater sources, replenishable groundwater resources are around 430 kilometer cube. So, that is sort of the total water we have into the different utilizable forms, either in the surface or in the subsurface. However, there are further limits on utilizable quantities of water owing to its non-uniform distribution. Water is not distributed again uniformly over the country, as we have seen the global picture where water was not distributed uniformly across the globe. So, if we go on a country scale, so same thing we can see here, that the water is not the available water is not distributed uniformly across the country. We have different states with different kind of water resources scenarios. Okay. It is well known that the Rajasthan, Gujarat and quite of Maharashtra belt is dry regions, very little water availability. Many of the southern states are pretty rich in water resources. So, that way the non-uniform distribution limits the utilizable quantities of water. We can say that okay, total this much of water we have for total on a country scale, we have let us say x number n number of rivers containing some substantial amount of water for uses, but if those are concentrated in a particular zone in a let us say 3, 4, 5 states. So, it is not possible for other states to draw water from these far distances, or sort of the political boundaries and regional boundaries and all that makes it inappropriate or inadequate to basically uniformly distribute the water. So, basin wise per capita water availability in India varies from as large as around 14,000 close to 14,000 13,393 as the number given, to around 300 meter cube per year. So, you see the degree of variation is almost 2 order here. There are places, there are regions, there are sub basins which has water per capita water availability as low as 300 meter cube per year, while others which are having more than 13,000 meter cube per year. The water availability per capita water availability has decreased on a country scale, has decreased from 6,000 meter cube in 1947 when we got our independent status, to just little under 2,400 meter cube per capita water in 2000. So, in around these 53 years there has been a large reduction. We got at that point of time we were 6,000 meter cube per capita per year, and we are now at around 2384 meter cube per capita per year. Now, this decrease is not largely because of the decrease in the fresh water quantities available. They are still available in more or less same, at least what we consider fresh water resources. There are other limits and issues onto sort of what is fresh water these days. There is a lot of pollution issues coming in, and the water that is in our river or in our lakes, or this what we call as a fresh water or usable water, is not although saline, but in terms of quality, how fresh it is or how usable it is another sort of very pertinent question in today's time. Still, even if we consider all that as a freshwater resources, still we have not like the total amount of water in these freshwater resources have not dipped that much. What we have done is we have grown ourselves in numbers. The growth of population has been immense, and that has led to the decrease in the per capita resources, not only in terms of water, in terms of land, in terms of various food productions and all that issues. So, because of the population growth, because of significant population growth, this per capita availability has decreased to this great extent. Now, again if you see in the numbers as per the Central Water Commission, which is available on its website, the see that the total geographical area we have is around 329 million hectares, which is 2.4% of the world area. Around 21% we have forest cover. The population, world's population is around 17.2%. The rainfall, annual rainfall is 12, which is sort of data of 2005 that you see here. The 2000 data of 2005, annual rainfall is 1208 mm. So, that is the rainfall, and if you recall what we were discussing in earlier lectures, that total rainfall across various continentals were of the order of 750 to 800 or something like that, except Southern America. All other this thing has rainfall of the order of that. So, that way the water inflow wise we are actually better than many places, okay, better than sort of most of the world that way, or not most of the world, but we are doing better than the average. However, because of this huge population and less area, the total water availability is not sufficient enough to feed in these many number of people, and that is what is leading to decrease or to reduction in the per capita water availability, annual water availability. The river basins, we have sort of 12 major river basins with the catchment area of greater than 20,000 square kilometer, whereas there are 46 medium river basins with catchment area less than 20,000 square kilometer, okay, and the total sort of area covered by these river basins. So, major river basins accounts for over 250 million hectares, while the medium river basins accounts for a little under 25 million hectares. Water resources data, if you see, so the numbers as you can see here, that the average precipitation, total precipitation is 4000 BCM, while average precipitation during monsoon is 3000 BCM. So, as around 75% of the precipitation, 3000 of the 4000 comes into these monsoon period from June to September. The runoff is of the order of 2000 BCM that way. The utilizable surface water resources 690, the total utilizable groundwater resources is 433, and per capita water availability as per Central Water Commission. This is the point that we were talking earlier, that the per capita water availability is at present around 1700 meter cube. So, the CWC estimates it around 1720 cubic meter or meter cube. If you recall, the international norms for declaring a region or a country as water stressed is less than 1700 meter cube. So, we are right on the verge of it actually. The total water per capita water availability we have is as per our official resource, which is CWC, is 1720, and as per international norms, if it falls below 17, we are actually under water stress, and many estimates in fact already consider India as a water stressed country, as you might have noticed in the earlier maps that were displayed. There are similar cases and similar data onto the land resources, total food grain production and all that. So, it is not that we are doing well in other terms, the status is similar for other things as well. Now, the water resources potential in the river basins of India, again this data is sourced from Central Water Commission. So, Indus, which is includes of Ganga as well as kind of Brahmaputra up to the border that way. So, Indus earlier is like the annual average annual potential in the river is 73, while Ganga Brahmaputra combinedly have over 1000, the average potential over 1000 actually. 585.6 is for Brahmaputra, Barak and others, while 525 is for Ganga. The estimated utilizable flow that way is 250. Okay. It is the data, similar data one can actually notice for the other rivers. So, each of them have a sort of different potential, average potential in the river, and the estimated flow is accordingly changes. Another sort of compilation of basin wise distribution again from the Central Water Commission source of their 1993 and 1996 data. So, sees that the Ganga Brahmaputra Meghna covers around 34% of the total area of the country, with average annual runoff of around 1100, little larger than actually 1100 kilometer cube, and the exploitable surface water that is available in this basin is 274 kilometer cube, much higher as compared to any other. If you see this table over here, the next higher exploitable surface water is available in your this river basin, which is Godavari. Then there are Krishna and Mahanadi are other major basins which have significant amount of exploitable surface water. The potential wise, if you see, so the major ones are your Mahanadi, of course the Ganga Brahmaputra are the largest one. Then you have Mahanadi, Godavari, Krishna is another big one, and then you have this Narmada. So, Narmada is having your around 35 kilometer cube of exploitable water available. So, these are the major river basin units, okay, which serves the country. Now, the Ganga, Brahmaputra, Meghna actually caters most of the regions in the northeast, okay, while your sort of Mahanadi, which is central east part, Godavari and Krishna caters the central part mostly, as you can see from these numbers over here. So, this is for central part, okay. And then of course, there are others, some contribution, smaller contribution from various other rivers, including your Kaveri, Tapi and all these. The Narmada is the major contributor in the western part, central western part. So, that is the sort of status of the contribution of utilizable, exploitable surface water in the various river basin units. The groundwater scenarios, if you see, are the groundwater scenarios are again not same everywhere. It will be sort of groundwater also varies, and the depth of groundwater is varies largely in the different places in the country. We will talk about that once we discuss the groundwater rather in detail. Now, if you see the total water usage in India, India's current water consumption is approximately 581 trillion liter, okay, whereas irrigation accounts for 89%, industrial consumption at 6% and domestic usage at 5%. So, very similar to the one that you saw earlier for the low and middle income countries, okay, where agriculture sector accounts for the most, okay. So, in India also 89% contribution is 89% sort of water demand is from irrigation sector, not actually demand, rather we should say 89% is used in the irrigation sector. Then there is a industrial consumption at 6 and domestic at 5. Of the major river basin, if you see that the population density of people per square kilometer, which is highest in the Uttar Pradesh, is served by the Ganga, and there water used for irrigation is 91%. The Krishna, which serves the Maharashtra and Karnataka with a population density of 253, again accounts for around 90% of water consumption in the irrigation sector. Then Kaveri and Godavari similarly, they are like in the Tamil Nadu, Karnataka, while Godavari in the AP, with population densities, varying population densities accounts for again huge, particularly Kaveri serves the 95% water goes for the irrigation sector, while Godavari again around 89% of water, which serves the Andhra and Karnataka with a population density in the river basin around 189 people per square kilometer. This is another the estimated use of water in the different sectors, total use of water in the different sector in 2010 from a report published in 2011 by Ernst and Young. So, the estimated numbers are 2010 and predicted number for 2030. So, the domestic consumption total, all these figures are actually in billion cubic meters. So, the domestic consumption is in 2010 was estimated to be around 34 billion cubic meter, while industrial consumption around 41 billion cubic meter. The staggering consumption was in agricultural sector, accounting little over 600 billion cubic meters. The interesting thing, because India being a growing country, of course, the demand is going to increase in all the sectors, and that is what has been estimated. So, estimated consumption in 2030 is 66 billion cubic meter in domestic sector, around over 90 billion cubic meter in industrial sector, and around 674 billion cubic meter in agricultural sector. Now, quantitatively if you see, the increase in the domestic demands or domestic consumption is almost 30 billion cubic meter, industrial it is around 50 billion cubic meter, and agricultural it is little under 70 billion cubic meters. So, still the increase in the agricultural demand is highest if you see in terms of the numbers, but interestingly if you see in terms of the percentage of the total expected increase that way. So, agricultural sector, the increase of little under 70 for a consumption, existing consumption, if you consider 2010 as a existing consumption. So, for a existing consumption of 606, increase of 74 is or increase of 70 is just around 12% or so. So, but if you see the increase in the domestic consumption, it is almost doubling the number. So, that way near 100% increase in the domestic sector, industries are more than doubled. Okay. So, around 120%, 120 to 125%, that much of increase in the industrial sector and is expected, while agricultural sector the increase is very minimal. That is because India is a developing country, we are going more and more towards the sort of industrialization and infrastructure development growth. The urbanization is taking place rapidly, leading to the increase in the domestic demand. There is a population growth. So, if you look at the drivers for these increase, the population growth and increased per capita growth are the basic demand drivers for domestic, whereas industrial expansion, industries like power, in all sectors in fact, and many of these are extremely water intensive industries. So, with this industrial growth we expect to increase in the industrial demand, and that is what has been predicted, while in the agricultural sector there is going to increase the demand of food grains. So, there will be again demand is likely to increase for water also, however, it is not going to increase that much. Moreover, there is lot of scope of saving water in the industry by using in the agricultural sector primarily by using the advanced irrigation technologies, because there is very poor water management reported, particularly in the agricultural sector. The over exploitation of irrigation resources are what people observe many times. Okay. So, that is what is so with this actually, if you okay, I guess we will end this lecture here, and we will continue in the subsequent sessions.